Hello everybody, welcome to NEET Physics by your own video channel. In today's video, we are going to solve a multiple choice question from the chapter Kinetic Theory of Gases. The question is, a sample of gas consists of mu1 moles of monoatomic molecules, mu2 moles of diatomic molecules and mu3 moles of linear triatomic molecules. The gas is kept at high temperature. What is the total number of degrees of freedom? Okay, how to solve this problem, sir? So, for example, you have three cases in this, three types of molecules are there in the gas. One is monoatomic, another one is diatomic, and the third one is linear triatomic. Okay, so in the so you have to find for the monoatomic gas, for a single molecule, the degrees of freedom is 3, that you know very well. Then what is the total number of molecules present there? If you multiply it by 3, then you will get the total degrees of freedom for that monoatomic molecules, all the monoatomic molecules. What is the total number of molecules, sir? For 1 mole of gas, for 1 mole of any gas, the number of molecules inside the gas is Na, which is your Avogadro number. In the case of mu1 moles of molecules, it is mu1 into Na. The total number of monoatomic molecules in this case is mu1 into Na. For 1 molecule, the degrees of freedom is 3. If you multiply it by 3 into Na, that is the total number of degrees of freedom for monoatomic molecules. Similarly, you should find the total number of degrees of freedom for diatomic molecules, and the total number of degrees of freedom for the linear triatomic molecules. Only, so the addition of all these things will give you the answer. As usual, you are given 4 options. So already, so you know that Na is the Avogadro number, that is the number of molecules in 1 mole of gas. In the gas, 1 mole of gas means what? Whether it is monoatomic, diatomic, triatomic or linear triatomic, whatever it may be, even polyatomic, its value is Na only. Okay, that's all. So then, let us calculate one by one. Degrees of freedom for monoatomic molecules is 3. Okay, that's all. Then degrees of freedom for diatomic molecules is 7. Sir, is it 5 or 7, sir? It is 7. Because at high temperature, in addition to the translatory motion and rotational motion, the diatomic molecules will have vibrational degrees of freedom also. So totally, the degrees of freedom for one single diatomic molecule is 7. And then you know the degrees of freedom for linear triatomic molecules is also 7. Both are 7 only. Okay. So then so these are these 3 and these 7, all these for a single molecule. There is the number of degrees of freedom for a single molecule. Then if you multiply it by the total number of molecules in each case, you will find the total number of molecules. So the total number of degrees of freedom for monoatomic gas, monoatomic molecules, 3 into mu1 into Na. For diatomic molecules, 7 into mu2 into Na. For linear triatomic molecules, 7 into mu3 into Na. So you can take 7 as a common one. So the total number of degrees of freedom is 3 mu1 plus 7 into mu2 plus mu3 into Na. What are mu1, mu2, mu3, sir? Mu1 is the number of moles in the monoatomic molecules in the gas. mu2 is the number of moles of the diatomic molecules in the gas. mu3 is the number of moles that is present in the gas, the triatomic molecules present in the gas. Okay, so sample of gases. Okay, that's all. So option A is the right answer for this question. Okay, that's all. So you will see one more question from the chapter Kinetic Theory of Gases in our next video also. Till then, thank you one and all. Thank you.